Section 5.4 talks about special parallelograms. Our first special parallelogram that we're going to discuss is a rectangle. And a rectangle is defined as a parallelogram with 4 right angles. So we have a right angle here, 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 and here. Now obviously if we were given 3 right angles, we could subtract in 360 and find the last one's a right angle. But that would be the minimum we would need to know that we have a rectangle. A rhombus is just a parallelogram with all sides congruent. Remember, a parallelogram had opposite sides congruent already, like this. But now we're saying all 4 sides are the same length, which most people would say, oh, that's like a characteristic of a square, which is true, but that's only because a square is a type of rhombus. A rhombus can lean like this. It doesn't have to have the right angles. So basically, if we combine the wonderful powers of rectangles and rhombuses, then we end up with a square, which is a parallelogram with all sides congruent and all right angles. So square is a type of rectangle and a square is a type of rhombus. So taking a look over here at our first example, it says quadrilateral ABCD is a rhombus. So if we know it's a rhombus, we know all sides are congruent. And it says find the measure of each angle. So we're looking at ACD, looking at this angle right here, I'll call that X. DEC, we'll call that Y. EDC, call that Z. And ABC, I'll call that W. Now we're going to have to try and find some characteristics of a rhombus. Now if you noticed here, if all sides are congruent, and we said the diagonals of a parallelogram already bisect each other, then what we end up with is these two triangles are congruent by side, side, side. Same thing with these two and these two. And what we find out is we have 4 congruent triangles by side, side, side. Now before I go ahead and solve these, I'm going to show you that the fact that we have 4 congruent triangles by side, side, side gives us our next couple of theorems. Before we go on and do those theorems, you should pause this tape and try page 186, 1 through 6, to help you with your classifications of these 3 special parallelograms. Okay, hopefully by now you've gone and completed those problems and not just let this play through. And we'll start with theorem 512. The diagonals of a rectangle are congruent. What this means, if I have a rectangle, this segment is congruent to that segment. So if this were A, B, C, D, if it's a rectangle, we say AD is equal to CB. Remember, this is not a characteristic of all parallelograms. Parallelograms just bisect the opposite angles, or they bisect the diagonals. These diagonals actually are the same length now. Theorem 513 says the diagonals of a rhombus are perpendicular. That means that these meet at a right angle. And we also have theorem 514, which says that's a really bad rhombus, that each diagonal of a rhombus bisects 2 angles. So if I draw a diagonal of a rhombus, these 2 angles end up congruent to these 2 angles. And they actually end up congruent to these 2 because, remember, opposite angles are congruent because it's still a parallelogram and it has all those characteristics, but this one's split in half, and so is this one. Now, I made my rhombus kind of square looking, but these would also all be congruent here to each other. On a square, obviously, since it's a rectangle also, we would actually end up with all these angles being the same and all these segments being the same. And remember, since a square is a rhombus and a rectangle, this applies to squares, this applies to squares, and that applies to squares. Okay. Theorem 515 seems a little out of place when you first look at it because it's talking about triangles now. It says the midpoint of the hypotenuse of a right triangle. So if I label the midpoint of that right there is equidistant from the three vertices. Well, we know it's equidistant from this vertice and this vertice because it's the midpoint of here of this hypotenuse. But what we didn't already know, which we know now, is that that length is the same as the distance from there to there. Okay, and actually the reason it fits in here is because if we copy this on the other side here, we end up with a rectangle. And these four pieces would be congruent in a rectangle. Theorem 516 says, if an angle of a parallelogram is a right angle, then the parallelogram is a rectangle. So if I'm told I have a parallelogram here, and I have one right angle, we say, oh, well, opposite angles are congruent, and the same side interiors are supplementary, so we end up with all right angles, and we conclude it's a rectangle. 517 says if two consecutive sides of a parallelogram are congruent, then it must be a rhombus. Well, we label it like this. If we're told this is a parallelogram, we know opposite sides are congruent. Opposite sides are congruent. Oh, then it must be a rhombus. Now, before we move on, you'll want to try page 186, 7 through 10. Some very good problems there to help us dig a little deeper, and then you may continue. All right, hopefully you completed those problems with the greatest of ease. Uh, Now we're going to look at our example here that we were looking at before. Instead of having to go through the steps of showing that we have four congruent triangles here, which is how we knew that the diagonals bisect opposite angles and that they meet at right angles, we're just going to use those properties of a rhombus to find these measures of these angles. So, since we know that the diagonals of a rhombus meet at 90 degrees, we've got a right triangle here. We can find this angle. And we also know that a rhombus bisects opposite angles, so this is 50. This is 90. This has to be 40, because we have a triangle here. And we know that these angles are equal. We know this, and this. And then we know 50 and 50. And now any angle it asks for, ACD is 40. DEC, DEC is 90. EDC, EDC is 50. And ABC, ABC, which is this whole angle, is 100. That's that. Next, we say quadrilateral MNOP is a rectangle, and we have a 28-degree angle here. Well, once we know that we have a 90 degree, this should be 90 degrees total. So 90 minus 28 is 62. And then we have 62 here, because remember, these were all equal. So that means we have an isosceles triangle here. If we want to find this angle, 62 and 62 is 124. And we subtract from 180 to get this little angle right here, which is 56. Okay, so let's see what they're asking for. PON, PON, well, that's 90. It's a rectangle. PMO, PMO, oh, we found that was 62. Segment PL, oh, there's a typo here. There was supposed to be a length measured given here. Right here was supposed to be like 10 or something like that. So that's PL would be equal to LN. Oh, that kind of ruined it for me. And then MO is going to be 20 because the diagonals are congruent. Our next example says ABC is a right triangle. M is the midpoint of AB. And remember we said if AM equals MB, then they're equal to MC also. So if AM is 7, then MB is 7. AB is 14, segment addition, and CM is 7. And next it says if AM is, oops, not AM. If AB is X, Then AM is, obviously it's half of x, MB is half of x, and MC is half of x, because they're all equal. That's the end. Great job.